Hi, we are Team ME23. My name is Michael Savio. My partners are Alexander Nanai and Matthew Bernier. Our faculty advisor is Mr. Tom Mealy, and our sponsor is Mr. Rivera Anselmo. And our project is a manually operated guillotine maul wood splitter. This project is a continuation of last year's to make a completely hand-powered wood splitter style as a classic guillotine. The goal is to be able to cut a log that is 30 inches in diameter by 30 inches in length, using a trigger for release and being satisfying and fun to use. This year we emphasized reliability, safety, and consistency for this device.
Since the goal is to improve the previous year's design, the engineering principles remained largely the same. If you look at the table on the left, you can see seasoned and green logs of varying diameters and the minimum force it would take a hydraulic splitter to cut them. If we know the drop height, force of gravity, weight of the cutting head, and the log length we're cutting, we can use the equations on the right to figure out the minimum pound force per second it would take to cut logs of varying sizes.
This is the model given to us by last year's team. It consists of a single vertical I-beam on which the cutting head rides on. There's a boat winch style crank to raise the cutting head into position and release by a plier clamp. They left us with an unassembled idea of a safety bar to release the cutting head on command, while the entire mechanism has a wide base to support the structure, and the blade has a four-way split.
The most important addition that we made to the device this year is our safety bar. We designed this as a lever around a fulcrum point on the I-beam track. The lever is connected to a set of pins that engage the head as it is cranked up the track. Once the head is raised to the top, the pliers release and the head falls on the pins. Pushing in the safety bar creates a trigger mechanism that we can use to drop the head when we want, instead of the way they had it last year, which was the head would be cranked to the top, and once the pliers reached the top, they would automatically release the head, which was not a very safe method.
Other additions to the rig include the winch being changed to have 2 handles instead of 1. This was for ease of use and so that the user would stand behind the cutting head track instead of off to the side as it was before. A dummy wheel was also added so that the total number of turns required to raise the head was decreased, and support brackets were added on to help stabilize the top piece of the track.
On the first test, we assembled the guillotine easily in less than 15 minutes. The design of the safety bar worked seamlessly, with the automatic engagement being perfect and having enough resistance but not too much. The safety bar was able to be pushed in so that the cutting head could drop. On our third test, the bearings failed and torqued, causing loosening of the cutting head and making the safety bar far less effective. The subsequent wobbling of the cutting head on its way up prevented the safety bar from engaging properly, and we would need to fix the cutting head in the future. We made several major improvements from last year's cutting head design. We added steel reinforcement plates to counteract the torque produced from cutting and splitting wood. This reinforces and strengthens the cutting head's ability to stay level and straight. We added a pin plate before the first test in order to allow the safety bar to engage to make it a more safe mechanism. We added a steel clamp to replace the bearings. The first test exposed that the bolts holding the bearings were not strong enough to withstand the force and torque placed on them, and this negates that torque and allows the cutting head to stay straight after its contact. We also added 90 pounds directly above the cutting head to assist in splitting.
Our second round of testing was done with 200 pounds falling from a drop height of 9 feet. The table on the left shows that every log size tested was able to be cut. The videos in the previous slide demonstrate that smaller log sizes were able to be cut into 4 pieces cleanly in one go, whereas the larger logs would split in half on the first cut and required several more cuts to be able to be split further. The table on the right shows the theoretical versus the achieved pound force per second for the smallest and largest log sizes tested.
After testing, we determined it might be a good idea to pursue a detachable head. It could be replaced with a single-bladed classical axe head, for example. Another recommendation would be to extend the length of the wire cable by about a foot so it can reach the cutting head at the bottom of the track. A third recommendation might be to modify or just create a whole new system for the plier clamp mechanism that holds the blade, the cutting head, as it is raised to the top of the track, as it has not been reliable and consistent through our testing.
A major future design recommendation would be the addition of a wood collection and transportation cart. This would allow for safer splitting because the split logs wouldn't turn into projectiles. It also allows for transportation of larger logs, which could be difficult to transport. It provides for a safe base on which to split wood. As you can see in the second testing video before, the wooden base which was used to chop was chopped by the falling head. This was a concept that we were told to hold off on and focus on splitting wood, so it never came to reality, but it's recommended in the future.
In conclusion, the Guillotine Mall was able to successfully and cleanly split much larger logs than the previous year due to the weight addition. The safety bar worked consistently and reliably, greatly improving the safety of using the guillotine. The bearing replacement plates also worked consistently, not breaking at all during testing, and the guillotine is even closer to being able to compete with a hydraulic splitter. With a few of the minor modifications and fixes suggested, the guillotine would run even more smoothly, and it's not infeasible to assume that it could cut a 30 by 30 log, as we were having no problem cutting the log sizes we had available to us during testing. Thank you for watching.